When we designed the Aricode printer, we put all our preconceptions from all the many generations of printers on the market, including the ones we designed in the past, to one side and tried to look at the product from the perspective of the customer. We realized that what our customers want more than anything else is reliability. So we tried to apply this idea to every aspect of the product, thinking that every interaction the customer has with the product gives the impression that it just works all the time, every time. We started with the ink cartridge. How can something as simple as an ink cartridge go wrong? Well, you could be adding the wrong ink. You could add ink to the solvent by mistake. The ink could drip when you remove the cartridge. It might just be difficult to insert it. We figured out that if we make sure the air is connected last or disconnected first when we insert or remove the cartridge, then the ink would be airlocked inside. So we made our inlets different lengths. We then added a physical interlock so that you can't add solvent containers to the ink port nor ink containers to the solvent port. Then we added a chip to the printer so the printer could tell what ink you were putting inside. Then we looked at how you hold a cartridge and sculpt it at the end to make it easier to hold. Our next point of attention was the user interface. Reliability for UI means being able to do exactly what you want quickly and easily. We decided to fit a large touchscreen and give it the same usability as a smartphone. The software is designed so that any screen can be accessed with only 1 or 2 clicks, displaying as much information as possible on every screen. Every screen has only a few icons, giving access to the message editor, the print engine controller, the print log, and the admin page. Many users will not need to leave the home page most of the time to get the printer producing codes. The touchscreen is surrounded by an all-metal enclosure. Reliability was foremost in our thinking when we made this choice. The enclosure allows us to seal in the main electronics PCB, keeping it free from dusty or moist environments, which are harsh on electronics but commonly found on production lines. We figured out a way to remove the heat from the electronics whilst keeping them sealed in and without having to add any heat sinks or ribs on the outside of the printer. This keeps the exterior of the printer smooth and makes it easy to clean, and the electronics is sealed so it doesn't pull air or moisture. It can be washed at the same time as other production line equipment. Perhaps the least reliable thing on any inkjet printer is the print head. We thought about what makes a print head unreliable. Inkjet nozzles block, drop generator performance drifts with temperature, high voltage deflector plates trip, and it can get dirty, which stops it working properly. The first choice we made was to add a valve to the droplet generator to seal the nozzle when the printer's off. Not only does this keep the drop generator free from dust, but also allows us to thoroughly wash the internal surfaces of the device in shutdown, and so we ensure the print head is filled with solvent when it's off. Our startup routine has been carefully developed to ensure a reliable start day after day, month after month. We designed our droplet generator so it consistently produces perfect droplets by following the laws of physics. We fitted a heater directly to the drop generator so it always operates at the same temperature, whatever the temperature of the environment is outside. This means the performance of the printer doesn't drift from season to season. The code that's printed in winter is the same code that's printed in summer. The print has been designed using 2 high voltage plates of opposite polarity. This ensures the same strength field as used by others, but halves the voltage on each plate, meaning the clearances needed between the high voltage plates and neighbouring metal components is easier to achieve both through the air and across surfaces. A large distance between metal components across surfaces makes the print head more tolerant to surface contamination such as dust and dried ink. Even so, we've given the print head gloss finish so it's easier to clean. All these design choices have strongly contributed to the fact the Aricode print head is the smallest on the market. Although it's small, it can print up to 48 drops, which is more than any other product on the market as well. Even with all these precautions, sometimes things can go wrong, and we're proud that our printer contains a unique plug-and-play printhead module. If the nozzle's blocked, for example, because of a power cut, then the printhead can be removed by undoing 3 screws and replaced in under 5 minutes, including the time to initiate printing on the replacement printhead. This has been designed to give our customers ultimate peace of mind. If the printhead has a failure, you don't need to wait for hours for a service technician to repair your printer. It can be changed quickly with a screwdriver. We realised too that when we clear unused ink from the print head, if we apply too much vacuum, then we run the risk of pulling dust into the print head, undermining its reliability. So we devised a smart algorithm that controls the pump according to the viscosity of the ink, so that it pumps harder when it's cold, i.e. when the ink's thick, and more gently when it's hot, when the ink is thin. This has the positive benefit of making sure the printer is very economical to run. When the ink returns to the printer, it passes through our degassing device. This removes air from the ink while preventing the formation of bubbles and foam. Not only does this make our printer more reliable, but it means we don't need to add extra foam suppressants to our ink, giving us a much wider range of printing options. The heart of our printer is our ink system module. In thinking about the ink system's role in reliability, we realised that good filtration is the key to effective functioning of all the components. Changing a filter should be something that's routine maintenance and doesn't need a skilled service technician to perform. So we decided to make changing the filters a process that is quick and easy for anyone. Simply open the door, undo the fixing bolt which extracts the filter pack, remove and replace the filter pack, and tighten the bolts to resecure the filter. We put a chip on the filter pack as well, so you know when to replace it. In other areas of the ink system module, we've also looked at how we can improve reliability. We've designed a pressure damper that ensures the printhead supplied with a constant ink pressure whilst eliminating the failure modes that's common in other devices. We've looked at how the viscometer might fail and designed the probes to prevent false readings. We designed a membrane for the flush pump which can be collapsed and inflated perfectly without creasing. Although the ink circuit's complex, we figured out a way to design it without needing internal pipes. This reduces piping errors and the possibility of leaks. We made sure that we mounted all the solenoids vertically to reduce the possibility that a solenoid will stick. In taking care of our ink, we realised that keeping it cool will increase its performance. We designed our cooling system so that it pulls up air through air filter in the door and then through the ink system before being exhausted out to the bottom of the printer. As you might expect, changing the air filter is easy and doesn't need any tools. The Aricode A2120 is a product that has reliability and innovation baked into its DNA. It's why we've already have more than 10 granted patents protecting all of the ways we figured out how to make the product more reliable. The Aricode A2120 is a product that is reliable and innovative because it was created that way.